right, hello everyone. Welcome to the Road to the Metaverse Creator Series. In today's session, we're going to learn how to add multi-user capabilities to your Unity immersive experience and explore solutions for deploying social experiences. My name is Drew Demokas, and once again, I'll be your MC for the session today. I joined Unity back in 2020 as a creator and developer advocate, mostly focused on showing businesses how AR and VR can solve problems and modernize old processes. Now let's meet our hosts, starting with Jerome.
Hello, everyone. I'm Jerome Moret-Delaunay, a senior advocate here at Unity on the industrial team. You may have seen me before in the previous episodes. If you're new here, my colleague Ben and I started this series last year, and now Vanessa and John have joined this fantastic adventure. But yeah, I spent about 20 years in digital production, 10 years in Flash, 10 years in Unity, mostly XR, and I'm really happy to see you here. I guess I'll hand it off to John next. There we go.
Hello, John Futcher, also senior advocate here at Unity with Jerome. Also been using Unity for over a decade in games and industrial uses, XR, networking, and all the like.
I guess now is my turn. I'm Vanessa, and I'm the baby of the team, actually. I'm the creator advocate, and I've been at Unity for roughly 6 months, and my background is in computer game development. And I'm here, as Jerome said, to support this amazing series. Thank you all.
All right, thanks again, everybody. So just going to quickly throw our agenda on screen here. So after just a quick introduction, we're going to go into the main topic. Now, just the usual few housekeeping notes before we get started. If you have any questions at all, please type them into the Q&A section, the Q&A pod there on Zoom. Questions to us tend to get a little lost in the chat, but that'll guarantee that we'll be able to get to those around our Q&A towards the end of the session. The session's also going to be recorded, and the on-demand version of this webinar will be made available in just a few weeks. So as always, we're looking to hear from you about how we can improve our presentations. So I'll quickly fire a link to our survey into the chat. It's also available, the QR code on screen there. Please fill out that survey when you get a chance. It really helps us be able to continue doing this kind of programming. And yeah, before we go into the main topic, I'm just going to highlight a couple of helpful resources, first of which is the Road to the Metaverse Executive Series. So in this series, kind of our sister series, Ryan Peterson, Unity's VP of Professional Services, is joined by special guests, and they tackle the kind of the why and how behind this new era of consumer and social experience. There are currently 5 episodes on demand, available at the link at QR code on screen, and there's a 6th session due to be added soon. And again, I'll just put that link into the chat. And just one last thing for me here, I'd like to shout out our Metaverse Minute blog. There's a number of great stories to be found in this blog, many of which I've actually featured throughout our series, so feel free to check that out when you get a chance. Lots of inspiring Metaverse use cases and Metaverse creator stories to be found in there. But yeah, with that, I'll hand things over to Jerome.
All right, let me grab the screen share. Thank you, Drew, as usual. And there we go. You should see my screen. So welcome everyone to this exciting session. I wanted to remind you that we do have a dedicated GitHub organization called Road to the Metaverse, where we'll be uploading today's projects, but you'll also find previous projects. Actually, you'll find the base project for today's demo that's already there. That was from episode 8. So lots of source code, packages like the visual scripting extension for XR interaction toolkit that will also be used here, the notification system for visual scripting. So lots of useful stuff for you to use in your project or to share with your colleagues or co-workers. And also reminding you that after this session, we'll post the link to the slides along with the links to the project's source code in our forums. There's a dedicated thread for today's session, so we'll put everything there. If you have questions or need further information or further details, don't hesitate to post in the forums. John, Vanessa, and myself will be happy to engage there. It's very useful and we get quite a bit of traction. And also it's a good way to go back to the other series and find some of the all the slides and all that good stuff have been posted there for the previous episode if you're looking for some reference. And today we are going to focus on building a collaborative multi-user experience. So actually I would say that this is one of the hardest things I had to take on as either a Flash developer or a Unity developer, is creating multi-user experiences. If you think, normal production is difficult, but you can probably multiply that by 4 when it comes to networking, because it's just basically a minefield with tons and tons of stuff that can make things a lot harder. Before we start actually looking at some of the concepts and ideas behind networking, I wanted to let you know that you don't have to necessarily start straight inside the Unity editor to prototype your multi-user experiences. There's actually dedicated tools that do that a lot more easier and a lot better. I invite you to check out MultiBrush, which is a multi-user version of the Google Tilt Brush product that's been deprecated, but thankfully Google uploaded the source code onto GitHub, and now the community has taken on and created new product, both MultiBrush and OpenBrush, which allow you to kind of easily collaborate in VR and create user experiences right there on the fly without having to necessarily use the Unity editor at all. But good news is actually they built all of those 3 tools are built with Unity, and usually there are ways to export that data into the Unity editor, which is quite brilliant. ShapeXR, again, is actually really dedicated to user experience. It's collaborative also. It's a commercial tool. But I highly recommend you check it out if you are developing VR experiences or immersive experiences, VR, AR, or anything in between. It's a really good tool to that comes with tons of components that you can just drag and drop in your scene and kind of collaborate on user experiences. And then finally, Gravity Sketch, which is really full-featured collaborative environment, not only to 3D model, but also to create user experiences or mock-up user experiences with ton of export capabilities. So highly recommend you check them out. Again, all of these are made with Unity, which is quite fantastic. Now, into the introduction to networking. So there's a few concepts or few things you need to be aware of. John, myself, will cover them, some of them more in details throughout the session, but at a high level, basically, you need to have a network identity, which is you need to know who and where to find each other. You need to have network authority. That means the who's in charge, basically, right, of ensuring that the simulation is in sync with all the other actors. There's various models when it comes to connectivity, finding each other, who's in charge, whether it's a client, whether it's a dedicated server. There's obviously several ways of synchronizing or harmonizing the simulation across the network. There's latency, which is how long does it take to send messages back and forth, whether those messages have to have, for example, delivery assurance like HTTP protocol. So when you request an HTTP pages, there's a guarantee that the content will get there, but that means that you need to inform the server that things have been delivered. So there's like some back and forth traffic versus UDP, for example, which is another way of sending information. When you just shoot the information, if it arrives, great. If it doesn't, you don't care. You're just sending out that into the ether. Hopefully it gets there. And then finally, there's security, which is the main thing. If you're doing something internal where you're not going to open this to the wider internet, let's say, then you don't have to worry too much about security if you're behind firewalls, but it's always should be a consideration. Do people need to authenticate? Is the client host, for example, can they compromise the data? Can they cheat also, right? This is usually the issue with a client-hosted system. And there's a lot of consideration there. The sum of this is actually on our netcode for GameObject page, which you can find more information around those concepts for networking. And one thing we wanted to highlight, one of those is the network topology or the network model on the previous slide. And there's 3 main ones. The first one is peer-to-peer. So basically, this is just synchronizing across client. No one is technically the host, right? It's just the information is synchronized or exchanged between clients. There's no central connection, right, between those clients. They just find each other organically via the networking protocol. Then there's client hosted, which means that a client, so one of the players in a game or one of the users in a multi-user experience is also going to run the server side of things. So they're both going to run in the same application. And this is mostly what we're going to cover today, because out of the box, we don't need to set up any other infrastructure. And peer-to-peer doesn't scale really well, especially across the web, so it's better to use a client host. And then ideally, if you have a lot of concurrent users, or if you want to make sure that the simulation is safe, that no one can hijack or compromise the simulation locally, then the server authoritative, the dedicated server is really the way to go. And that ensures that none of the clients can influence the server. All the simulation is done on the server. So technically, when you, for example, in VR teleport, well, you're not teleporting locally, you're asking the server to teleport you to that location, and the server will either say you yes or no, depending on, whether there's a wall in front of you, but the server is the authority here. And that's really, when you scale, especially publicly available experiences, the best way to go. But it's also the heavier lift when it comes to setting up all the backend necessary or scaling, for example, your server architecture, in order to do so and deploy your content. We will be focusing on the first half of the session on netcode for game objects. So this is a pretty recent update to, replacement to UNet, which was the traditional Unity networking stack that has been deprecated. And netcode for game objects is a set of high-level APIs that allow you to basically create multi-user experiences inside Unity. It includes network manager, network identity to find each other, and network transform to send data, for example, transform data in Unity, so your position, rotation, and scale. On top of that, John is going to demo a few items, part of the Unity gaming services. So Drew mentioned there was a session recently on the Road to the Metaverse Executive Series dedicated to Vue.js. So I highly recommend you check it out. There's a lot of wealth here of services and tools. Most of those tools are actually not Unity editor or Unity engine specific. They're agnostic. They work in Unreal. They work in web-based, for example, for Vivox, which is our voice transport system. So all of this, there's a lot of things about monetization, etc. So basically, the bread and butter of free-to-play gaming comes from Unity gaming services. That's where developers, creators make a lot of their money. And those services are available. Specifically, we're going to focus today on Relay and Lobby, which are a way to connect each other, find each other across networks over the internet. And there's also a matchmaker, which is more, we won't focus on this today, along with multiplay. These are ways to scale infrastructure, for example, when it comes to dedicated servers, organically or automatically for you. And then matchmaker is a way for player to be pooled together, put onto a server to play games, etc. So enough with introductions. Now let's go into the meat and potato of the session. And we're going to start with getting started with netcode for game objects. And John is going to take it away from here on, unless there's questions already, but otherwise we can proceed.
Nothing in the Q&A right now. So yeah, go ahead, John. So we're ready to
jump
go.
in if everybody can see my screen here.
Yes.
Yeah.
Okay, so we're going to jump right into the editor and cover a lot of the stuff that Jerome just brought up. So first thing you need to do if you want to set up netcode for game objects in your project is you need to get the packages. All these packages are available from the Unity registry. And if you just go to the Unity window, package manager, and pop this open, and after this kind of updates, you can search in here for the various packages. Just to save time, we've already imported the packages that we need. So we have our netcode for game objects package, and as well as Relay and Lobby, which we'll be talking about in a little bit. One of the things to note also is that there is a dependency for those things that also requires authentication, and that will grab that for you automatically when you grab that. So once you have these packages imported into your scene, you can jump right in and start working right away. So the first thing that you need to do, and we've got a few examples kind of set up already in our scene here, but we'll walk through it one step at a time, and then we'll kind of build up into more complex examples. But the first thing you need to do if you want to create networking setup with this is just go in here, create an empty game object, and we'll just call this network manager for simplicity, or network manager. That works too.
That sounds delicious.
And we can add our network manager component. This comes in with the package that we imported. It's a available component to add to an object. And the first thing it asks you to do is pick which transport you're using. And we're going to be using the Unity transport. That's the new transport system that netcode for games are built on. So when we do that, it'll automatically set up our transport setup. So it'll add the components we need, give it some basic, reasonable default values. And then from here, basically what we need to do is we're going to go through and we're just going to change our debug level to developer, because that's going to log out the different things that it's doing, so we can kind of see how it's working when it's running. And you'll notice here that there's also a player prefab object that's empty. So the player prefab object is the thing that it's going to spawn for every user in the experience automatically for you when you connect. So it'll handle the basic connections, and once you connect, it'll create this without writing any other code. It's going to take this object, whatever object this is, this prefab, and it's going to spawn that into the scene. So to make something usable by netcode, we need to add a few components. So let's just make a quick example real fast. So we can make a new object. Let's just make a capsule. That's your classic first person shape. But it has our basic, mesh, renderer, capsule, collider. But to make this usable on the network, we need to add something called a network object script. Now, all this is doing is basically it's doing some kind of bookkeeping under the hood that allows Unity to keep track of this object, tag it as a networked object, give it an ID that's going to be usable by the networking system, and allow it to be kind of propagated over the network. Now, having it just tagged usually isn't enough. So what we want to do next is we want to add something like a network transform. Now, this is going to automatically tell the system that I want the transform, the position, rotation, and scale of this object to be synced across the network through all the attached users. So anybody who connects, I want them to be updated when this object moves. So we can see our position, rotation, and scale. And the nice thing here is it kind of asks you, like, how much of this do you want to sync? So if we don't care about syncing the scale across the network, we can turn those off. And we know we're never going to move on the X or Z axis rotation, then we can kind of turn those off. And the idea here is that sending data over the network always comes with a cost. You want to make sure you're keeping that footprint as small as possible. You want to keep that data as limited as possible and only sync the things that really matter between the clients. So you keep those packets kind of as small as possible.
Hey, John, you can also, I guess, limit the amount of data you send by using the thresholds, right?
Sure. So if you go into the network manager, you can kind of set various settings of how much you want to, send.
On the network transform, there was where you had
Sure.
it. There was those set of thresholds. I guess those are the minimum values of change, which is really useful.
Right. So it's not constantly flickering back and forth for tiny changes, or if there's like a inconsistency in like the rigid body system or something like that. And you can also tell it to basically interpolate, which is going to smooth out the motion of that object instead of taking like hard locked steps. It'll kind of try to smooth that out over the network. So the other users will see that kind of moving around nice and smooth. Now, just to get this to show up on the network, this is really all we have to do. But obviously we'd want this to move around a little bit. So we can do something like we're going to add a minimal first person moving script. And this basically would, just allow it to kind of walk around and move on the scene. Now there's a quick gotcha here, and I'm going to throw this up and I'm going to press play just to give, oh, I missed one thing. We're going to let this load up, and then just to show you the issue here. So if we do this, you'll notice that we're not getting our input and we didn't show up yet. So on our network manager, now we want to take this object and we'd replace it with this object. So typically we'd make a prefab and we drag that into our network manager. And this is going to be the object that's going to spawn. So this is the new one we made. So if we took this, we would just make a prefab out of it by dragging it down, and then we would throw this up into the network manager. And then this object is going to be the object that's going to spawn when we connect to the other users. And at this point, we can kind of turn this one off. And I just want to turn this on just to kind of show the initial setup here. But there is a gotcha here, and we're going to cover that because this is a common thing that happens to most people when they first set these things up, is we want to make sure that we can have ownership of our objects. So real quick, we can see over here, we have our server, host, and client options. This is just from a real basic UI that all it's doing is running one line of code that's going to say, I want to be the host or I want to be the client. So now it's saying, okay, I'm the host. I have my object. Here's my object. It popped into the scene. It's a little bit too low because we didn't set our position. We're exactly where we wanted. But that wasn't the point right now, because we see that it's up. We see it syncing to clients. And we can also, join it from other setups. So we have another one that's joining right now. And we can see now that there's another client connected. Now we're also not getting movement, and it's down in the ground. So what's going on here? Well, unfortunately, or fortunately, depending on how you look at it, but this is a common catch for most people who are first starting out, is that by just adding a network transform and just trying to move it on the network, it's not quite enough, because what we really want is we want the clients to be able to move their own objects. But by default, the server and host setup here is server authoritative. That means the only machine or system that's running that has the ability to move any of the objects is the server. So just by saying network transform, I'm going to be moving this, it's going to be okay. This is going to be running on the client side. The inputs to move this around are running on the client side, and the server isn't getting that information, and the server is saying, no, this object isn't moving, I'm not moving it. And now if you want to have authoritative server, you want people to cheat or get access to things deeper, that's a good thing. But if you just want to get something set up basic and quickly, it's kind of a catch. To do this, what you normally have to do is write some code to check to see if this is if you own this object. You also would be changing these to be, these scripts are actually network behaviors, and I'll show that in a moment. But as a quick example, I'm going to close these out and show you a quick workaround. So if we go back to our other network manager here with our netcode UI, we have a different object, this first-person minimal compare controller. So this one we already set up, and you'll notice it has the same exact objects that we already can set up the other one. It has a network object script, it's got the minimal first-person mover, but the network transform is not just a network transform, it's a client network transform script. Now, this script automatically flags an object as being owned by the client so that we know that the client has the authority to move it around. And this comes from a special package that you have to install directly through a Git link. So if you go back to like the package manager, you have the option to add package from Git URL. And this is another Unity package. It's a package called the multiplayer samples package. And you can add that directly through a link, and we can post that link and we'll add this to the resources that we have so that people have access to this. But I think this is a great thing that doesn't come directly out of the package, but it is another thing that Unity has up on the package, like available to be added, and it allows you to quickly get set up and running. So let's start this back up, but with this netcode manager. And after a moment, when this runs, we'll start another session here. So now we're going to start the host, and we have our minimal mover, and we see it's in and it's moving. Here's our scene view. We see it moving here. And we're seeing that we have the scene is initialized, syncing to the clients, but we only have one in here so far. Now, if we go back and we look at our setup, we'll know that all of this is only running locally immediately. So, oh, we have a new client. Who's that? So one really cool tool that I think everybody should be aware of when you're trying to set these things up is a tool, and you can see the other person's moving because that is just me as well. If I drag over my other view, this is the same setup running in another instance of the Unity editor. So I have another clone of the same exact project sitting on my other screen here, running on the same machine using a pretty cool tool called ParallSync that I've been using for a while. And I'll just jump over and kind of explain what that is. ParallSync is another Unity editor extension that basically allows you to make clones of your project locally in a safe and updatable way. So basically, you can use this window to just drop down to select making a clone of your project. It will make a copy of that project locally through symbolic links. And then you only have to work in the one main project. Any change you make in that project will automatically be updated to the clone. So you only have to work in the one. You don't have to copy changes over to the other or even go through a repo. It's all linked locally. But then it also allows you to run it in another local Unity editor. So you can have multiple sessions going at the same time. And I find this to be super valuable when you're trying to test network things. So I can just have this set up and running here, like here's one editor, and then I've got the other editor here, and I can see them, being updated at the same time. Super valuable, saves a ton of time. So just wanted people to be aware of that. So now we've got two sessions, kind of, you can see my secondary kind of in, like looking around. We've got two set up in walking around. They both have control through this client network transform script. But this is just 2 clones on my same computer. That's great that it kind of sets up basically, but if you see here, it's using the local loopback IP basically. It's all running locally on my machine. This is great if I just wanted to test locally and get things set up. Highly recommend working through these. But what if you wanted to connect to other folks? What if you wanted to work with other folks over the internet? Most people do. Most people don't just set up networking just to have it run locally. So to that end, that Jerome mentioned, we have a few new services, and one of those is called Relay. And Relay is an interesting service in the sense that it isn't so much I wouldn't call it a server per se, because you're not running your simulation on it. It's basically a redirection service, an internet traffic cop, as it were, that allows you to connect to other players or other users over the internet without having to write your own NAT punch through and writing your own network connection protocols. This handles the ability to have different computers connected through and I think Relay is a great name for it because it's through basically a quick relay where it allows that communication to pass through and get to all the other users without having to do all that hookup yourself. And if I just grab this little UI right here, it kind of tells the story of what this does for you. So I'm just going to press play. And I think I missed one thing. I'm going to jump back out to change it. But what it's going to do is it's going to allow you to sign in and get your regions. So basically through this, it's going to allow you to allocate your relay and get a join code and then join that relay. So these are the steps of the process. This UI comes with the package basically as one of the examples that you can use to kind of learn it. What this does for you is it does the signing in, does authentication through Unity authentication services, so you know who's connecting. It allows you to automatically find or select the best region through which you want to connect. It allows you to make an allocation, which basically is setting up that service, that session on another machine somewhere that's going to allow that communication to be passed through everyone. And then to get a join code, kind of like what you'd see in like a Jackbox game or something like that, or other kind of networking setups, that you can use this join code to then join with other people by typing in that code. And then using that code, you can join the session and then you're connected over the internet, and that's all you need to do. So I'm going to unplay this again, and I'm going to turn on a different UI that I made to go with that simplifies that. And I'm going to go back to our network manager. I'm going to change our protocol type to the relay Unity transport just to make this fully connect. So now those steps that I just showed in that little UI, that authenticate, getting the region and all that, I wrote code that basically on play, it's just going to do all those things automatically. It's just going to go out, it's going to do the authentication, it's going to get our regions, and it's going to be ready to kind of allocate a session. And so once I'm in, I can press these create game button, and it's going to do the same thing we saw on the starting host, except for now it's going to spawn me into the session automatically because I wrote the code to make it do that, using those same services. But now it generated this code, this 9868PJ code. And if some of my fellow presenters are watching, who's that?
That is me.
It's me too.
Hi, Vanessa.
I'm here too.
Hi, Jerome.
Let me share my OBS so people can see my editor. There we go. I'm in the editor too with the same project open.
And you can see that all they needed to do was using this bottom part of this UI that I put in here is that when I read that code out, they just typed in that code, they hit join game, and now we're all networked into the same session. I can see them moving around. I can see somebody nodding at me with our little capsule with our helmet. And that's all we needed to do. We're connected over the internet. I'm in Buffalo, New York in the US, and Jerome's in London and the UK. And, we're...
Vanessa is in Brighton. Yeah.
Oh, yeah.
UK too.
Yeah. So we're connected from all over. And that's all we needed to do. We set up it's the same exact setup that we saw before. It's using that network manager with the prefab. When they joined that session with the code, it created that prefab for them. It's using that client transform script to allow them to control their own instance, and we each have our own camera, and we can kind of look around and see each other walk around, and we can do something together. Now, this is a really cool service because it's super lightweight. It doesn't require, like, you don't have to make another separate build to put up on a dedicated server and allocating server resources and all that. And it allows you to connect things, quickly, simply, get things up and running. But also sharing that code can be kind of a pain. If I make this, do I have to be on a Zoom call with the person that I want to join with all the time? How am I going to give them this code? And I'm not going to type that to them or talk to them all the time. So to that end, I'm going to boot everybody out.
Oh no!
Sorry. To that end, we have another service called Lobby, and I should note that all of these services can act independently of each other. You don't need to use these all at the same time. They can all work on their own in their own use cases. But I do find that they work very well together, and they kind of build on each other to allow this kind of seamless networking setup. So now we're building on this. We say we've got this lobby system. So what does this do? So I guess I'm just going to press play. And if some of my colleagues want to jump in as well. This little menu that I made up right here allows us to use the same relay system that we saw, which is built on the same netcode system that we saw, same netcode manager, same characters, same prefabs. But under the hood, it's allowing us to create sessions that are joinable and that can share data. So we can basically create a session and, give it a name. I don't know if people are cute. Was that you, Jerome?
No, that was
No,
me.
actually,
That was Vanessa. So Vanessa created, so if I just hit search lobbies, I can see that she created a session called Purchasing Pro, and there's one person in it. And all I'd need to do to join it is, this is a button that I made with this. I can just click this button and I will join that session. And now we are connected, and that's it. We didn't have to share code. Oh, now it looks like Jerome joined us as well.
I got FOMO. I'm surprised Ben is not here actually already, because probably also has the major case of FOMO. So.
Yeah, and so that there's a lot going on in that one little screen, but it makes it super easy without sharing any codes, without having to call anybody on on Zoom or text anybody a code. It uses the same relay system where that's how we're kind of connected, and we're sharing data. We're networked through that same relay session, but we found each other through that lobby system. And so the really cool thing there is that, kind of under the hood, without going too deep into it, that lobby system allows us to basically add data into that system. So I'm just kind of real quick throwing up a little bit what's going on in here. So this is the class that I kind of wrote for that lobby manager. There's a bunch going on. It looks like there's a lot going on here, but it's actually pretty straightforward in that it's basically on play. It's doing the same things we saw before. It's authenticating. It's getting the information for each person. It's giving the option to quick create or join a lobby. And when you create a lobby, it's basically using that same relay system. So this is the code that you'd use to use the relay system to allocate a session for relay, get that code, and then I'm embedding that code into a dictionary of data that I'm associating with that lobby. Now, that lobby keeps that dictionary of data so that when later on, when somebody clicks that button, I can use that lobby data to join the relay service by looking up that same code from that data that's associated with the lobby, and we don't need to share it, and it all just works. So it takes a little bit of a setup, but it's once you have it kind of up and running, it's really straightforward and kind of really pretty straightforward and simple to work with. So yeah, I think that kind of gets us through most of this. I think we'll note that there's a few things to be aware of. This system right now with Relay is targeted mostly at smaller group sizes. So you're looking at groups for around like 10 or so users at a time. And that's usually like the recommended number of users generally is around 10 or so. But so if you're trying to do something that's going to have a lot more users all at the same time, all in the same session, then you might want to look into something more like a dedicated server or multiplay and some of the other services that we have. But for getting a few people into a training system and getting them up and running, it's pretty great. And it didn't take us a lot of setup. It took a little bit of code to make things simple, but a lot of the basic setup for it is fairly straightforward, and there's documentation for all the steps that I walk through up on the Netcode for Game Objects webpage. And it'll walk you through a lot of the same stuff. And I see folks nodding along next to our skid loader here. Very cool. Do we have any questions from Jerome or Vanessa? Anything that you feel like we should touch on this before we kind of move on to the next part?
No, my only question was actually if are the service relay and lobby available for other platforms other than Unity, but I think you covered that. These are not only, they're not netcode specific, right?
Right. So the relay and lobby and matchmaking and multiplayer services are all engine agnostic. You could use it for other things that aren't just Unity. But I do feel like that what we showed is a nice kind of flow of like the things they used all together. They build on each other really nicely, but you could use them all independently. Absolutely. We're keeping this alive here right now. I just will make one other quick note that if you're going through this and you're setting this up, one quick gotcha too is to make sure that if you're setting up a lobby and you're set like Vanessa did, you want to have some code in there that will do what's called a heartbeat. And there's examples of this on the site. If you do that, it kind of sets a basic recurrent. So right here is kind of just like a real quick like coroutine that basically pings the server every X number of seconds, and you want to make sure that that's set up. Otherwise, it will automatically deallocate itself after 30 seconds. So if they don't just stay up there indefinitely. But as long as your code is running and you have that kind of coroutine running, it's just a boilerplate code. I believe it's right up on the site if you go through the things, but I do want to mention it that if you forget to do that, you might be like, hey, what the heck? I just started a lobby. It disappeared on me. You got to make sure that it's running that heartbeat and just give it like anything under 30 seconds on a recurrent kind of ping to the server. But yeah, so with this, cool. It's all pretty much set up. Some of the other buttons, I'm gonna drop everybody out. Sorry. So clearly, Vanessa uses this create lobby button. She just wrote in a name, hit the create lobby. That associated that name she wrote with the lobby, and the data with the join code was already all captured automatically. And this quick join button just kind of jumps through that same stuff. It just but speeds it all up. But it's very easy to set this up on your own. If you follow the rest of this, hitting that quick join button basically just checks to see, are there any lobbies available that have room in them? If so, join them using the data that's provided through the lobby that you got. If there isn't, make your own, and it'll just make the a quick join lobby name and throw it up there. So yeah, I think that pretty much covers the basic setup of netcode. There's a few other topics that we didn't have time to kind of go into right now, like things like RPCs and kind of setting up this making events kind of trigger on other systems, spawning other objects. But just a quick note on that, just like the first person character, if you wanted to spawn objects on the network, this is where you'd add them. This network's prefabs drop down. There's a list here. You can add basically prefabs, and the network manager is aware of any of those prefabs so that you can spawn them on the network and then have them be synced as long as they have a network object component on them. So if there's any questions about all those other things, maybe we can get those into overtime, because I believe we have some other stuff that we want to get into. Any other questions or things we want to hit here right now, Jerome or Vanessa, or do we want to move on to the next part?
No, unless there are a relevant question in the Q&A, because we don't want to Drew, Vanessa, you wanna? Well, I guess we'll do Q&A afterwards. I think they're pretty. Let me check quickly with the banana. How to use it in VR? Well, I think there's no spoilers. This is going to be
what I was thinking, yeah.
This is going to be the next section. I'll grab the screen share while you're there, John. Yes, and we'll see the same scene. As you can see, no tricks here, right? You can see the same scene as John was showing. That was in the editor, except mine is kind of orthogonal view here. But we were using his project in order to demo everything. So actually, I'll minimize it now. This was the current session. Let me go to my notes. Right, we did that again. Parasync, really good library to basically synchronize two projects together and then use that to quickly prototype multi-user experiences. Good news also is as of 2023.1, we have a package that's coming up. It's an experimental package. You have the information there. It's similar to Parasync, but it's going to be built into the editor. So if you are exploring, the latest versions of Unity, 2021.3 is going to come out of beta probably this quarter or pretty soon in the next couple of months. So that will be the current text stream for Unity, and that package is now available, so you can actually generate up to 4 players in order to test multiplayer directly inside the Unity editor. So we have the instructions there. It's quite simple. You just add this package by name, .unity, multiplayer, tools, and then you will see the multiplayer play mode will appear, and that allows you to set this up, add those up to 3 extra players, and the main editor, which is the one that you're developing with, obviously. And then when you press play, that will fire up those 4 windows for you automatically. So we'll share the slide in the forum afterwards if you need more information on this. So a lot of people were asking for the links. We'll have them also in the forums. So next up, we are going to look at not 1, but 2 libraries to rapid prototyping inside Unity, and obviously using XR. We're talking about immersive experiences. Totally possible with netcode for game objects, but you have to roll out a lot of your own code in order to make it work. So we thought that not everyone has the patience to do it all from scratch, although I highly invite you to check it out because it's very efficient and obviously built in. And Normcore is a high-level API that you add to your projects, basically a set of packages, again, to add the functionality, basic functionality, just like you will see with netcode for game object. It's quite similar, actually, right? They all require the same element to synchronize a transform, to synchronize a rigid body, for example, if you want to sync physics, but they make it a little easier out of the box because they're very tailored towards immersive experiences and I guess games also. This is a commercial service when it comes to the hosting of the lobby relay for your experiences. So there's a free tier, which is quite generous, so you can get started with that. And then they have a pro and unlimited section. They also work, you can run them locally. If you are an enterprise customer that cannot operate this type of experiences on the cloud, you can host those locally on your network. They have an enterprise tier. And then after that, we also are going to look at Photon. I'm going to start with Normcore for the basic setup. And then we'll look at how to do it with Photon because it's actually quite similar, just different set of components that you need to add or code that you need to generate, and actually very similar to what John has done for the first project. So let's jump in with our trusty pug into the first project, which is going to be the Normcore one. So I'm going to pop in my notes. There we go. So we start here with episode 8, just like John, which is the immersive training experience that we did then with XR Interaction Toolkit, visual scripting extension for XR Interaction Toolkit, and the notification system to get started. And basically, let me go into maybe a more palatable layout. There we go. That's less scary. I'm going to put this here. There we go. So let's look quickly at what has changed from the previous version, from what we had to update before we actually even went into networking. So if I look at my project here, I have my state machine. For those of you who are new, you can go back to that session, which is available on demand in order to view how this works. But we had this training state machine, which was a very linear one. Where we start here. This is the first step when we get into the simulation. And then we have a condition in order to go into the next step. And that condition was quite simple, is we get a notification saying like, hey, the step is complete. If it's not equal to the current step, obviously, like if we're on step 0, which is the start, then go to the next one, right? So that was the all the code needed to run locally. Now, to run on the network, I don't want the client necessarily to be responsible with updating this. So I want to relinquish that to a network event. So all the clients connected get the same event. And that's where we had to kind of switch the state machine a little bit to look like this. I like the look, actually. It looks like a bit of a octopus or something like this, or a jellyfish. But basically what we do is we have this any state. So this gets evaluated regardless of where you are within those states, right? So within any of those states, if a condition here is true, then you're going to transition to that state. And the condition is now a network step complete, and a value is passed, which is the current step. So if we had 0, for example, step 1. So in this case, we evaluate 0 because that's the first step. And if that's true, then we go into that transition and transition. So I go back here, transition. Hello, thank you. Into that step. And here is 1, 2, 3, 4, and 5, where we complete the training. So that was the kind of the main change that we had to do in order for networking to be working. And then obviously we also, I did a little script called NumCore step complete, but we'll cover that afterwards. As John highlighted, the first thing you do with NumCore, it's you download from the asset store, and it will automatically add the one thing I wanted to go into before we go into NumCore setup is also, obviously, we need a representation of the other player. So in the case of those two libraries, Photon and NumCore, you keep using your local origin, XR origin player from XR Interaction Toolkit. This is the player controller that you are going to control locally. We're not swapping it, like instantiating it, just like John did with netcode for game object. So everything is set up locally, and then the only thing that you need to do is set up a representation for the other players in order for them to play. So there's this prefab which comes with NumCore that you drag into your scene, real-time plus VR player, and this references a VR player that we have here, the Road to the Metaverse VR player, which basically, if I go into it, it has a real-time view. So that's kind of like the network view that we saw before. Real-time view, a real-time avatar script, and then a real-time transform, just like the netcode for game object transform, network transform, where I can decide to send position, rotation, and scale, right? And then each of the items in there, again, has a real-time view, a real-time transform, and then a real-time avatar voice for the head. So this is built into NumCore. There's actually voice sync, and then a mouth move, which animates the mouth when you speak. This is all built in, provided by NumCore. And for the hands, we also have, obviously, the real-time view and the real-time transform, right? So that's the only thing that we had to do. They actually give you a prefab. I just adapted it to my needs by adding the little Unity hard hat, so we knew that that was a industrial application. Now, to add multi-user capabilities, again, getting started, you set up on the NumCore backend an application key, and then you pop that application key into your project here, and that's gets you started with using the backend networking. Obviously, download the assets from the asset store, and that takes care of adding a scope registry and adding the packages that you need, right? As I mentioned, the local player doesn't change, right? This is still using the same, you don't necessarily modify the local version of the XR origin, you just synchronize, as I showed you, with the real-time avatar, the items that you want to synchronize, and you define them here. I want to reduce this. You define them here with the real-time avatar manager, where it takes the origin. So that's important because that's when you teleport, that's where you're going to move to. And then after that, the camera, the left hand and the right hand are local transform relative to that origin, right? And this gets synced over the network with your representation, your avatar that, for example, John or Vanessa are going to have on their machine. But if actually, if everyone is ready, I can jump into play mode and we can demo this quickly before we go further into the exercise, so people have an idea of what we are doing here. I'm going to switch my view to, actually, let me go into play mode first. So as John highlighted, this is doing everything automatically, setting up a relay, a room, which is similar to a lobby, basically. And it's doing all this for us in the backend. I don't have to set up anything. I can obviously do it manually also. Here, I'm letting the platform do it all for me. I'm going to switch to my scene and game view only, so you can see. Let's position this a little bit better. I don't know if anyone is able to join. Oh, I see there's already someone here. Perfect.
It's me.
Excellent. You guys cannot hear it, but there's also audio directly from the platform. So I'm going to join in also. I can teleport, turn around. I can see Vanessa. Hey, what's up? All right. And then we can start the experience as we did before. So I'm going to do the first step. And if you want, I can teleport here. Again, this is exactly what we did for the last session. You can see, I think John has joined also. I can see you both over there in the back. Awesome. I am going to raise my skid loader. There we go. Beautiful. And now Vanessa and myself can start popping wheels. There we go. If you want to help, there we go. Let's put this here. Obviously, we're going through the exercise together. I put my wheels. Let's put the last wheel. There we go. And now we can see we are instructed to lower the lift. You want to lower the lift? Up to you. All right, I'll let you do it. And there we go. We're done. The lift is doing a zero dance. Happy dance. Yes, happy lift. And you can see that we collaborated in VR and went through a training together, all three of us. So, Vanessa and I were collaborating, and John was the foreman, the manager that checked that we did everything right, and then will tell us if we passed. Yes, exactly. If we passed or failed the exercise. So let's look at how we synchronize this, because there was already questions about some of the items in the chat. I'm going to go back to the default view here, and we discussed the avatar, so you can see the avatar synchronized. I don't have the hands set up, but that should be pretty easy. You just need to add a mesh in order for them to be visible. And obviously, the reason why you're using this local avatar for you is that has the interactors that going to grab stuff locally. You don't want people remotely to grab things in your local instance. You want them to grab things in their local instance, not in yours. So that's why the avatar is different than the local user that you are using here. First thing we need to look at is how do we synchronize the progress? So I showed you the state machine, right? How do we do this? But how do we get those events over the network with Normcore? Well, Normcore uses a model system. So you create a data model, which is a simple class, and then you basically watch that data model. So if we go into this class here, which is the component that's get added to the state machine game object. So this is a real-time component that uses the Normcore progress model. And the Normcore progress model, you create it. Sorry. Yep, let's go there. Thank you. You create it here, right? All you need to do to create a model is create a new class, add this attribute here, real-time model, and then for every variable, you add a real-time property attribute where you define its ID. So in this case, it's 1, whether it's reliable. So reliable means you want it to be delivered every time, right? If it's false, then it's just going to send the data, but not care if it's received or not, right? So this will be unreliable, will be something that you're going to send, for example, a lot of like a position update or something like this, right? Where you can interpolate. If you lose a couple of messages, you can still interpolate between the latest and wherever the user was before. If you need something to be delivered like an event, you want to make sure that all the experiences are synchronized, and you use reliable, keeping in mind that reliable obviously assumes a round trip to either the server or the host to let them know that the message was sent. Otherwise, they're going to try to re-deliver that message to make sure it's received. And then create the change event. This is because in the backend, I'll show you in a second, in the editor, all you have to do is create this part of the code, right? And here you can see this code was auto-generated. How do you auto-generate this? Well, if I look at my Normcore progress model, there's a couple of buttons here. If I compile the model, this will automatically generate this code, which is going to take care of scaffolding the whole class, adding listener, so we can listen to change events in our code. And if I go back to our Normcore sync step progress, you can see here that I am listening to current step did change, right? And this is, again, a function or an event that was created for me by the Normcore package. I did not have to write this. They auto-generated this for me just for convenience when I click the create model. So that's super convenient. They also create the public variable. So I created obviously a private variable. They made it public for me so I can use it, right? And here you can see when we, in case the model gets changed or replaced when you load the, when you enter the room, then you can deregister from the old one, from the old event, register to the new one. But basically, when you get this, you go on current step dechange. That's the function that gets called every time one of us completes a step, right? And then everyone gets notified that the step is complete, and then we go to the next one locally, but it's synchronized at the network level. So that's how you do those. Behind the scene, you can also use, I mean, if you want to, you can also use raw RPC events with Normcore, but they have this model system to kind of abstract that complexity and make it a little bit easier to generate those that code and that data. And then here we can see the little event bus that register. This is the classic, if you follow the series, this is part of visual scripting that has its own event bus that you can hijack to send event through to state machines or to other graph machines or script machines, sorry, running in the scene. Now that's for the state machine. And again, most of it is auto-generated by Normcore, but you do need to create a little bit of code. And then we have the wheels. So our wheels are in step 3, I believe. Let's see, let's go to the scene view, select the wheels here. Yep, there we go. And I can focus on that. So as previously, they have a rigid body, so they react to physics and gravity. They have a XR grab interactable. This is part of the XR interaction toolkit. And I realize that we're almost at time, so I'm going to speed up a little bit. And then there's a real-time view, which handles the object synchronization, and a real-time transform. And finally, you can see that the real-time view is aware of the fact that, the real-time transform is aware that we have a rigid body. It's asking us maintain ownership while sleeping. For example, that's when I release that object, I keep the ownership of it so that the physics simulation takes over and the wheels can drop. If you don't do that, they basically stay frozen in midair because you're no longer simulating them locally, and no one else is in that instance. And then I have a little script here, which is not necessarily required. I realized afterwards, all it does is, as John earlier mentioned, you have to request ownership of objects in order to control them. This could have been done simply by using these interactive events on first on activate or on select. Basically, when you grab that object, you can from here add a request to basically take ownership of the object. So you don't necessarily use that grid, but that's all you need in order to network that object and then transfer ownership to whomever grabs it in their local running simulation, right, or local running experience. And then finally, there's the garage lift, which is here. It's exactly like the progress. We basically have a model and a class that synchronizes the data. The model in this case is the lift height, which just exposes one variable, which is the height value, and then assigns that or sends that over the network by updating the model like this. Sorry, like current step, but this is not the right one. It's this model, sorry. So, oh, I lost my class. There we go, sorry. By updating the height model, so every time you set the value of the model, it gets synchronized over the network. And here I have a little threshold, so we don't send it too often on every frame, only if it changes to a certain value. And then behind it, you have again those events to register for more information, right? So Photon is going to be very similar. What I'll do is I'll cover it after the Q&A into overtime because I want to leave room for questions now, if that's okay. Let me go back to the slide and then we'll finish up for the session here. I wanted to mention Mirror also, which is a very popular transport, API, transport layer, etc. Open source, available for the community. This was actually a good replacement for UNet for a while until Network for Game Object came online. So highly recommended. There's quite a bit of documentation, obviously release titles that use Mirror, and it's open as far as which transport layer you use, what backend, what kind of relay. It's really, really good. Highly recommend you check it out if you want to have this type of solution. We recently, like 2 months ago, that was released a really cool demo, racing game demo using netcode for entities this time. So if you're interested in dots, if you press, for example, V Rising, which is quite a successful vampire RPG game, that's using dots. And so, it's getting traction in the community. A lot of people are using it now for the games, and there's a netcode for entities dedicated to that. And this demo has a full source code and obviously covers some of the key topics, even including Vivox. So check it out. As usual, thank you. I know we have a lot of content that we've been producing for this series. The next one will be built geolocated social experiences in AR. So we're going to look at geolocation. We're going to look at some libraries in order to create more social experiences, but also how to collaborate in AR. In the next episode. Our next live learn is spatial audio. So check that out if you want to, first of all, learn about audio, if you're not familiar a lot with the topic of audio. So we'll cover that, but also we'll look at some of the spatializer options to add true spatial audio into your XR experiences. And finally, the GitHub, the forum, the social, and then let's go into Q&A. Right at time.
All right, awesome. Thanks, Jerome. I'm just going to grab the screen share for the closing slides here for now. Feel free to grab that back if any of the questions are best answered in the editor or anything. But yeah, I'm just going to snap right back to our first question from 8:13 my time this morning. How can one implement ShapeXR, Gravity Sketch, or Tilt content directly into Unity, as Jerome mentioned back at the start of the session?
Yeah, so you can't implement it, but they have export capabilities, and because everything is created in a Unity version of sort, the assets are usually quite compatible, to import inside Unity. Some of them, like Tilt Brush and Open Brush, they have actually packages that allow you to export the data and then import it easily, because again, all the shaders, everything are available, so you can really import it perfectly inside Unity, just like you used to be able to with Tilt Brush.
All right, awesome. I'm just going to throw it out there. We've got a bunch of questions here, so I'm going to kind of be rapid firing one to the next here. Okay, next question. What about the sync of the animations and parameters?
Yes, so
sure.
So go ahead, John.
Well, I was going to say, the netcode side, just like we showed the network transform, like there's other components there that also you can add that sync different components. So there's a network animator component as well that can sync your animator over the network as well. So you would add that just like you would add the network transform, or there's a whole slew of networking components that we didn't have. Of course, we're trying to cover a ton of stuff, so weren't able to show everything right now, but there's a ton of networking components that will sync those different components over the network. You just got to take a look through that package, but most of the commonly used ones have a network version of them now.
I'm assuming for like values, like the height of the garage lift or an int, like the steps you go into RPC calls with netcode for game object, or do they have something specific?
Sure. So to answer the next question, I'll just read this. Sorry, jump on ahead. So one of the ones is it's related as well. It says, how would you handle syncing script value like player score with netcode? So I'm just gonna take the share back for 1 second, and I can show a quick answer to that. So one of the things that I mentioned, but we didn't have a ton of time to get into, is that one of the things you'll do when you're working with the code for these things is you would write, you'll notice here that this is not a mono behavior, it is a network behavior. Network behavior basically extends upon mono behaviors. So it works all the same way. You have all the same things that you would normally have, like awake and update and so forth. But it also gives you access to things like events like on network spawn or on network despawn. So these are the things that you can do that you want to handle in code. Like once this object is spawned on the network, this is how you do your bookkeeping and such. Or like, I want to, disable the camera, or I want to enable it when it despawns and stuff like that. Similarly, with a network behavior, you can also add a thing called a private network variable. Let's say int, and we'll call this my score, right? And so by making this a network variable on a network behavior, this variable will be synced over the network. There's also some limitations that you can apply to that, of like who's allowed to write to it, who's allowed to read from it. Can only the server change it? Can the client who owns it change the score themselves? But that's all you need to do to set it up initially, is to kind of change that, to set that network variable up. That said, network variables have to be primitives. They have to be things like an int, or like a bool or something like that. They can't be a class. But you can make your own structs. So you could use things where you could write your own struct to then, as long as you can make that network serializable, it will work to sync those values automatically over the network using the networking behavior stuff.
Awesome.
All right, nice. Okay, next question up here. A bit of a suggestion for a future session. I was wondering a lot lately, could you do a special episode about Unity collaborative setup if at least, say at least two people want to work in a project simultaneously? Our audience member here hasn't seen a good tutorial on that. I think it's something that's really missing, especially for students.
Post in the forums, and then we'll give you some pointers as to solutions you can use, please. I'll pop the link to the forums in the chat.
Perfect, thanks, Jerome. Okay, next up here, how do you save the definition of a network object from your example to a template, as opposed to creating manually from scratch to automate its creation when a player joins the game?
By template, I assume you mean prefab. Prefabs are basically templates of objects. So you build it up like you'd normally build up any kind of object. If you want to make any object a prefab, there's ways to kind of, right click it and create it into like a prefab. But the simplest one is take it from your scene view as you're building up, drag it into your project view, and it will create an asset, template of that object and create it to a prefab. And when it does that, you'll get that little blue highlighting with the little blue box. And then you can use the prefabs as templated objects that can be spawned into your game like any other, and on the network, applying them to the network manager as the player prefab, but also any other objects you want to spawn on the network would go into that list of network objects on that network manager that allows anything to spawn.
All right, awesome. Okay, moving right along. How's the collaborative work being used here if two people work on the scene? This parallel thing's pretty cool.
If you're talking about parallel sync, you only have to, it's only one, it's basically, I would use it myself, right? So I would use that to make a clone on my local machine, and it's all done through symbolic linking basically. So I only have to work in the one project. I could have 5 clones on my machine. I only have to work in the one project, and anytime I save my scene or make changes, they'll all automatically match the one that I worked in, so that when I press play, I can go to those other ones and press play, and then I can take all those game views and I can have them all networked on my own local machine running together, but in the editor. So that gets you out of having to make the builds and all that. So it's not like having multiple clones. It's like I'm working in each clone. I only work in the one, and all the other ones are kept in line, and so it's just great for testing.
There is a library that we'll post in the forum that allows you to do collaborative scene building. It's not made by Unity, but it's a third party.
Okay, cool. Yeah, and just a reminder, Jerome posted our forum link in the chat there if anybody's looking for the forums. Next question. If you have multiple people, how do you test multiplayer across different machines?
Just like we did. Across multiple machines, I guess you can you can sync with Git or Plastic, for example, multiple projects across, if the machines are around you and you can have access to them, but if it's multiple people, they need to sync on their end. What we did here is all of 3 projects today were on Plastic, and when John made a modification yesterday, we just this morning pulled the latest version, press play, and we go into the editor together. Obviously, you need to commit those changes if you do them, on your end, because they won't be shared with John or Vanessa, for example, in this case.
Excellent. Okay, next up, if developing an enterprise application in a restricted network, are there any special ports that need to be open for this to work in enterprise networks?
That depends on the tightness of your firewall, I guess. Enterprise network, I know customers that are pretty much sealed off, so that won't work for them. But John, do you know the punch-through capabilities? I'm assuming we rely on some ports, right, to be open.
Yeah, and you can set those when you're setting it up. Yeah, like I think you answered it right. It really depends on the network. That's so variable. It's hard to answer that directly. But generally speaking, like your average household or business firewall, like it'll allow you to connect over those. If you're in a super sealed environment, then there's other things you could do to work on-prem if you needed to. Like if you wanted to just work locally without going to the internet, there's other ways to set that stuff up.
All right, cool. Okay, next question. Can we export this example to Android APK for client player?
I don't see why not. Yeah. I think there's only a limitation for WebGL with netcode for game objects right now, right? If I remember correctly, John. But other than that, yeah, it works. NGO works everywhere, and then Photon and Normcore should be the same.
I believe the only current limitation on netcode for game objects is it doesn't specifically work on WebGL, but I believe it should work on all other platforms.
Perfect.
All right, great. Okay, moving right along. Is that lobby that we're looking at today hosted on an independent server, or is it at your developed machine?
Well, to kind of go back to some of the stuff that Jerome showed in the beginning, trying to think about this is a little bit different, is that the lobby itself, the lobby service is a cloud-based service. So that's a service that you would activate on your Unity dashboard, and you'd link that service up in your editor. We didn't cover that directly. I can share my screen quickly to just kind of show you where that is. But beyond doing that, so if I go here and if we go here, and now it's compiling stuff because I just changed things to answer the last question.
We're live, people.
And yep. You gotta love when it's reloading that now. So anyway, those are services, and you would link those services to a Unity dashboard, and so like you'd sign on to Unity's site and you'd set up relay and lobby, and you activate those as part of your dashboard. And so locally, if we look at our project settings, we can go in here and you can see if I go to services, well, I'm signed out, nice. So if I go to my hub and I redo that, I'll be able to sign back in. And so anyway, on that site, you'd be able to see the linked services. I'm not going to re-sign into the hub right now, but so the lobby services are on the cloud, and they're free, but with basic limits. Like if you start having thousands of people, then there's like a consumption-based model that I believe goes along with it, but they're free up to a pretty good number of users and data. I think it's basically data-based, and you're not going to be sending a ton of data back and forth. So the lobby itself, like that session where that data is stored, that's on the cloud. That's how we are able to connect to each other and find that data. And same thing with the relay session. It's a cloud-based service that's doing like that network traffic protocol that's making it so that our communications can make it to each other's computers. But neither of them are running a simulation. Neither of them are running a build of the experience that we put together. So that is running locally when we have a host. That's what we mean by like that's running locally on our machine, and everybody's kind of connecting to that host that's running the server on their own box. But we are able to find each other and connect over the internet to get access to that server through those cloud-based protocols. Did that make sense? Does that answer the question?
Yep. It does.
All right, awesome. Okay, can you switch back and forth from one session to another without exiting to the lobby menu-driven to see sessions while still in a given session?
Yeah, so there's no that UI, and I'll apologize for the programmer art. Like I put that UI together basically to show the functionality. And I have it turned off just for ease of jumping in and out for us to, like, when we join a session, it automatically closes itself out. But there's no reason you can't have that still running, still finding other lobbies. You can make lobbies persist, and there's also, again, this is a very deep topic and there's a lot of things going on, but there's also things when you talk about persistence and I'll being able to rejoin sessions when you get disconnected, or things like host migration, which we didn't talk about. Like, what if the host is running they're the server, everybody connects to them, they quit, they close down their session, but you don't want the session to be destroyed, like moving that so that somebody else can kind of take over ownership and start running the server on their side. It's called like host migration. Those are all deep topics that could be their webinars of their own.
All right, for sure. Yeah, kind of jumping in, lumping two questions in at once here, but basically, where and when will the project files from today's presentation be available?
So we'll put them on the Road to the Metaverse GitHub and post that in the forum in the session, but they'll be there hopefully by the end of the week.
All right, awesome. Okay, next up then, how many max users in a room for lobby?
Not sure if there is one explicitly listed. I'd have to go look at the documentation. But I know that you can go pretty high, because lobby itself is just like the connecting glue that allows you to kind of find each other. I'd be more worried about how many people you're trying to have be in a single session once it starts simulating. Once it's running on somebody's machine or it's on a dedicated server, then that's where you run into concurrency limits.
Okay, great, thank you. Okay, what if there are multiple scenes?
Sure, fine. Yeah, it's as long as you make sure to synchronize the scene loading across all the clients, then you should be good. Or obviously on the server if you're using a dedicated server.
Yeah, and netcode itself will actually to move between scenes and Unity, they all have to be part of the build settings. And if you're doing anything networked, actually netcode will throw up like warnings if you're doing anything and you're trying to like do something that using like a network manager and it's not part of your build settings and you try to like test it, it'll say, hey, if you don't have, do you want us to automatically add the scene to your build settings, because otherwise it won't be available to other people on the network to transition to if you do that.
Nice. I love those. That's really good.
Okay, next up here, the little green machine that was already in the scene, was that a client object or a host object?
That's both. It's an object in the scene, but it's not networked though. So basically, it's completely ignored by the network API unless we put a network transform on it, or we tell specifically that, hey, keep an eye on this. So in the local scene, if John was moving the skin loader or I move it, nothing would happen on the other instances. It would just be on my end.
Right, and that's a good thing, generally speaking. Anything that's like static or not moving in the scene, like you don't want to sync that. Everything you're syncing over that's more data that has to go over the network, and you want to keep that as small as possible. So anything that's going to sit still, it's fine to just kind of let it be local and don't worry about it.
Yeah, the wheels though were dynamic objects, so these had components to tell the network manager, hey, whether it's netcode for game object, normcore, or photon, to tell the API, hey, by the way, this is a network object. Please, keep in mind, keep track of those variables, right? And synchronize them across clients. That's the main thing.
All right, for sure. Okay, next question here. How would you implement voice chat?
There's another service that we didn't get into called Vivox. That's part of the same kind of suite of stuff. That's great.
Yeah, it's part of Unity gaming services. It's obviously cross-platform, works pretty much anywhere, including the web, and you can integrate that as one of the services that you sign up in the Unity dashboard. Both Normcore and Photon come with their own voice solutions, right? With Normcore, actually, we could hear ourselves inside the Unity editor as well as through Zoom, but the voice gets carried. And then for Photon, there's a Photon voice that you enable for your application in their dashboard and then add the required prefab into your scene, and it takes care of everything from then on. So it's pretty straightforward. But all those solutions are available here for voice chat. It's super useful.
All right, perfect. Okay, next question here. Can you touch on the topic of how to use VR trackers and base stations to say to track and transmit a user's location data in an arcade environment?
I guess that's kind of irrelevant how you track the user. At the end of the day, all you're going to send is that user's, headset and controller position, maybe a Vive puck if that's a thing to do, like full body tracking. But usually you send the data about the avatar that you want the other users to see locally in their simulation, right, in the instance of the game or the experience running. But how you get that data, whether it's inside out tracking or outside in tracking, the networking doesn't care, right? It's just going to synchronize a few game objects. Maybe John, if you have experience with more complex setups than just controller and headset.
Yeah, and I think you nailed it. The simple version is it doesn't matter how the objects in the scene are moved. If you're using trackers or pucks or headsets, they're at the end of the day they're moving the transform on an object in Unity. The way that would show up over the network or be moved over the network is the same as if you move that with a mouse and keyboard or a controller or anything else. So when people say is there specific VR examples and stuff like that, somebody asked in chat, it's like, it's the same. It's the same. It would work the same way. You can apply the same network transforms and objects and stuff that you would do if it was just bare metal and you're moving it with WASD.
Awesome.
Nice. All right, next up here. Let's say you were to build your sample scene. Could you build that so that any person could use it over their own Quest 2 that has not connected their device to Unity, but has connected via Wi-Fi and installed the build on their Quest 2?
Yes, we are running in the editor for convenience, so we don't have to build and run on device. It's also, kind of cool to be able to network inside the editor, so you can do a quick review of the state of a scene, for example, or of an interaction right over the network, or quick debugging as when you sync the projects across multiple users. But yeah, you can, once you build the UI that John showed, the nice developer UI can be adapted to be a in-game UI with all the options for the user to start a session, for example, and then everyone can join from their application. Yeah, you just use the Unity editor to create, debug, test, and then build the application to device, and then eventually, build and upload to a platform like Steam or the Meta store. That's obviously, yeah, after that, the Unity editor is out of the loop.
Excellent. I'm not sure how much this was already touched on during the main topic there, but we'll be going over Photon as well.
Yes, right after the Q&A, I'm going to spend 10 minutes showing you the difference between Normcore and Photon. It's super easy. I have the project open, ready to go as soon as we're done with the questions.
Okay, cool. And that also answers our latest question that just rolled in. Why should I use Photon over netcode? I guess we'll see in a second. Okay.
Well, actually, we can. So you can do the same thing with all three of them, right? Photon obviously is tightly linked to their backend services, right? Versus Netcode for Game Object doesn't really care what backend service you use, right? Whether you use our Unity gaming services or another a third party, we are an open platform, so we don't restrict you to one ecosystem. Photon is a commercial service. They have they monetize the usage of your application, right? By limiting how much you get, how much free concurring user you get for free. Then once you want to scale, you have to pay them money. So that's one of the consideration. And Normcore is the same thing. They have a free tier and then commercial tiers where they charge you money, but obviously you pay for the convenience of the service and whatnot. Right? It's the same with Unity. If you buy into Unity gaming services, we're gonna charge you for usage at that point. So the same way Photon and Normcore will do it, but with netcode for game object, again, you can use that with any backend, any system, including UGS or else, so I guess that's the difference. If you're happy to stay with all Photon, then, use their API and their backend services. If you're happy with Normcore, the feature set, etc., use that. If you want to roll out your own or use, a mix, then NGO, netcode for game object, or netcode for entities, plus some sort of relay, lobby, or backend of choice, including UGS, is a good option too. Not to mention Mirror, which is another option. So again, Unity is a big wide open box.
Absolutely. Okay, next up here, can one of the players be an Internet of Things device feeding the info into the room?
Yeah, absolutely. And if you saw our last session, I had an Arduino on my desk and I had a little breadboard with some sensors on it. And Jerome and I walk through how you can get that data not only just into Unity, but shared over the web. So in that scenario, you could have that driving other player in the room session. Also, you could use something like an MQTT server, that can just do pass through of the protocol, and you get that data in through that way as well without having to even go directly through the other stuff. You could even feed that into the server, have that update the clients if you wanted to do that, but yeah, the answer is absolutely yes.
Alternatively, if you don't want to use MQTT, you could set up the same style variable that you had, right? So if the client, for example, with the connected Arduino, changes a value, that could be synced via the netcode for game object API without having to add MQTT, right?
Yes, absolutely correct.
All right.
Yeah,
awesome.
please do it. We'd love to see, and post it on the forums. We'd love to see what you do with bringing those two sessions together, the Internet of Things plus the multi-user. Fantastic.
Absolutely. All right. How do you save a user's avatar info so they can customize it, and then all that customization info is available upon their return?
On the server, or you can save it locally on their machine using player variables that are available as part of Unity, but that's probably not a super scalable system. So you probably want to set up a backend where a database where you're going to associate that user ID with their customized avatar. I would assume that's the easiest and safest way to do so.
Sure. Yeah, next up here, what are your recommendations for using John's versus Jerome's setup? For example, pros and cons, or when to use each?
It's versus now.
Yeah.
I mean, I think Jerome covered a little bit of the pros and cons just a moment ago, talking about Photon versus NGO. They all have their own kind of sets of services, their own concurrent user limits, their own issues with or values when it comes to scaling. So it's a hard question to answer. Like, it really comes down to your use case. If you had a very specific use case, you could kind of do the cost benefit analysis of each and see what's important to you.
Yep, perfect.
All right. Okay, getting down to our last few questions here. Can Relay Server support up to 100 CCU? Are there any optimization issues?
So within a specific session, it's recommended to be 10 and under. So that when I say specific session, I mean in the same simulation, like we were all in the same scene doing a thing. That's in the same session. That said, you could have other sessions running. You're saying, like, let's say you make an experience and you make multiple builds of it and you have multiple rooms of it running all over. You could have any number of those rooms running. So you could, in theory, have thousands of people using your experience, but in each individual room, you want to keep that to 10 and under for the current set. That's the current recommendation because of the way that the communication needs to run and whatnot. It doesn't necessarily scale up to like 100 users. That said, if you wanted to do 100 users in one room, like a battle royale type scenario where you have 100 people in a specific scenario, that's when you probably want to look at something like our multiplay services and matchmaker, and like some of those are kind of like the dedicated servers, higher end stuff, and then you can those scale into being able to do that. And I think we also have a new sample out. There's a new, I think it's called like BR 200 or 2000. I can't remember the exact name right off the top of my head, but it is a like 100-person concurrent user networking example. You can find it online.
Yeah, I think a lot of the heavy lifting is actually on the backend side, where the backend synchronize each other to multiple dedicated servers running. So it's, obviously super efficient to network them, but not everyone is technically in the same simulation, although the simulations are synchronized. So yeah, that's definitely the best way to scale usage. If you have large user or large community to serve, check out Multiplay. It's used by a lot of very successful, massively multiplayer games right now. So definitely an industry-leading solution.
All right, excellent. All right, okay, what do we have here? Can we use netcode for streaming audio as well?
Not that I know of.
It's not really set up for streaming audio. Now, that said, if you wanted to play audio on other like clients or whatnot, the server can, tell the other users what audio to play, or if you want to sync up like audio cues or sounds that are going to be played at different times. That's when you get into like RPCs, remote procedure calls, and basically when something happens, you want, Mario picks up a coin, you want that sound to play on all the other ones, or they raise or lower the forklift. You can make that so that, but each player would be running their own audio locally. It just be getting the notification from the server to start playing that audio, and you wouldn't be streaming the audio from one device to the others. That would actually be very bandwidth intensive. Probably not a good idea.
Right. Okay, just 2 questions left here. How does Vivox deal with echo cancellation on an open mic speaker environment?
Ooh, that I don't know. I'm not sure what they provide as far as audio manipulation capabilities. So we will have to check the docs for that.
Okay, cool. Our last question then, is the breakout room feature implemented in GitHub? Is it implemented in the GitHub repository code, or are there any other methods that could be used?
Not sure what that is actually, the breakout room, because we had the lobby, right? Or I guess, but not necessarily like a breakout per se, right?
I'm not sure exactly what this is asking. If you're looking at the lobby stuff, I highly recommend going to the docs page. There's a great like getting started walkthrough. We gave you the real crash course today to kind of show people how easy it is to kind of get up and running. But if you wanted the actual like every little button you need to push, because we didn't talk about linking in the services and running the dashboard, they're very straightforward, and they actually have the reason we didn't go through them because it doesn't take much. They literally give you a prescribed do this, do this, do this, and it tracks you through it to kind of set up the service until you turn it on. And it'll and there's some code available, like the heartbeat code was literally taken directly from the docs, and they kind of recommend how to set that up. And so you'll find a lot of that directly on that page. So if you search for the getting started with lobby, you'll find most of what you're looking for. If you're looking for something else, please specify and we can try to answer more clearly.
Okay, they did just post in the chat that they're just looking for a way to implement a feature where they could create like a lobby inside the lobby and, like kind of split players off into, I think, smaller lobbies within the
it would
original
be like
lobby.
managing lobbies and then sending players to their own specific lobbies. But
in theory, I suppose you could do that if you set that up. The lobby system that we showed, where it kind of like you join the lobby or you create a lobby, it threw you right into the experience. That was to show how it can all be automated and ease of use. That says you don't have to leave that UI. Like if you wanted to create a lobby, you could join a lobby with other people and kind of like, do things where you have like an open chat. If you think of like an old school game lobbies and stuff like that, you could be in a lobby together where you could, be chatting before the experience starts. You don't have to start the experience right away. So in theory, you could be sitting in a lobby with a few other people and then, use the same code that you'd use to create that lobby to create a new lobby and assign user IDs to it and put them into their own breakout room. So yeah, I mean, that's an interesting question, but technically seems totally feasible.
Okay, excellent. That'll do it for our Q&A. So just in case anyone's leaving us right now, just like to thank you for joining. Of course, thank you for all those questions today. Love to see that much engagement in our Q&A. And thanks to everyone on, behind the cameras as well. Jerome, John, Vanessa, and Ben, co-creator of the series, who isn't able to be here today, of course. And once again, I'm going to post our survey link into the chat. But yeah, with that, since we are going to stay on for another little bit, Jerome, I believe you had some overtime in mind.
Yeah, let's do it. I'll grab the screen share and show the overtime. Woohoo! All right, everyone. We are now in borrowed time. We might be kicked out if someone needs our our webinar platform or something else. But we are going to look at Photon. I have the project running with my headset connected. I think right now I'm by myself. So very similar to what we've been on. Oh, there's Vanessa, or who's that? John? Not sure who that is. I see your head over there. So there's someone with me.
It's not me yet.
Yeah, it's me. It's me.
All right,
I
awesome.
was muted.
So again, we can start the experience. You will see, the progress updates. I can go to my teleportation area. Oh, a bit butterfingers. Let me raise this just to show that we did the same exact thing with Photon. And to be honest, I literally took the normcore scene and then remove all of the normcore components and just put the Photon ones in there. Rewrote a little bit of the code, and that was it. Vanessa, if you want to lower our forklift, there we go. You can see it. Vanessa is lowering it, and I can see it update on my end. And then we have the little forklift dance. Woohoo! Awesome. So there we go. Excellent job. And we are awesome. We are all done. So this is the simulation running here, as John mentioned. This is not using our lobby, but it's using Photon's backend and setting up a room for us. I'm going to go back to the regular view, my default view here, and you can see that the project is exactly the same. If I go to the training manager, you can see the state machine for the training is exactly the same, right? There's the modified one with the any state to jump from one section of the project to the next. In case you haven't seen episode 8, this is where the steps are, right? We have these steps which contain, for example, step 3 is the wheel. So if I had it, you can see the wheels disappear here. And basically when we go from state to state, it's enable and disable those objects in order to prepare the simulation for each step. So super simple. Again, that's from episode 8. Go check it out if you haven't seen it. And I covered, although hastily or quickly, the setup with normcore, but Photon is pretty much the same. Project setup, again, you go to their backend, set up a application key or application ID for you. There's the instructions which will link in the slides or in the forum if you want to ask, but it's soon getting started. You go to the asset store and there's a PUN, P-U-N, so that's Photon Unity Network version 2 free edition. There's a paid one also that comes with extra features, but there's a free version which you can download and use. This is the one that I use for the project today. And very similarly to John, with normcore, I had a prefab that I just drag and dropped into the scene. Here, just like with Network for Game Object, we need to set up things for this simulation to work. And basically, I have a Photon Network Manager, just like John had a Network Manager. And there's a little Photon Network Manager script which has a room name, and this is the room that everyone is going to join when they start the project, basically. And we can see here the Photon Manager extend a custom class from Photon, which is the mono behavior PUN callbacks. So that's a class that extends mono behavior but gets callbacks from the Photon API, right? And you can see here that on start, we connect to the server. Connect to server basically connects with the default settings specified in the project, and then connects to the master server and then sets up a room with the room options that we specify here. You see the maximum number of player is visible. I mean, is it public, and is open? Are we starting it basically automatically? And it's true. And then you just call the join or create room, and that sets up for you that room, right? And then on join room, basically you can log, whomever joined the room, or you can do instantiation of objects here, for example, locally in order to synchronize states between the rooms. And when the player enter, you get also a notification. I just use these to debug log format, like to debug log what was happening in order to see when I was testing. I'm not doing anything custom here. Then after that, I have a network player spawner. So similar to what John showed, this was actually built into the Network for Game Object API component where you could just drag a prefab for your player. Same thing in Norm Core. That was also mostly handled for you. Here you have to do custom, a bit of custom code. Again, very simple. I'm listening to the, I'm extending the mono behavior upon callback. I am specifying a string for the prefab. So this is a bit weird because we dragged an instance of the prefab before, but here basically what Photon does, it grabs this prefab from the resources folder. So in case you don't know this, resources is a magic folder in Unity. So be mindful, don't add a resources folder with a whole bunch of Photoshop files in there, because those are going to get compiled with your application and make your application size balloon. Plus you're going to bundle a whole bunch of useless information with it. So the resources folder basically encodes those resources for Unity to use at runtime, and you can access them using a string variable. So make sure they have unique names too, because otherwise things can break. But this is a very old setup. There's a few magic folders in Unity which have been there forever, like streaming assets, resources, and plugin. So be mindful of using those in your projects. The player, basically, you can see here when we join the room, we instantiate the player prefab, and when we leave the room, we destroy it, and that's about it. And that's all you need for the player lifecycle. Again, locally, I am using this instance of the XR origin. I'm not instantiating a local player that is visible. It is instantiated, but it's not visible. All it does, if we go into it, basically, is there's a bit of trickery here. So we can see that we have a head and the left and right hand that gets synchronized over the network. So these are the network player items, right? And then if we look here, there's a Photon network player. And this is a script that I have written. And it takes, obviously, those fields to synchronize those objects over the network. But also, it's going to use for my rig, XR Interaction Toolkit rig. And this is what it's using. I don't love this, the way it's set up. That's the tutorial I followed was using this. I'm sure there's a better way of doing it because it's looking for objects with specific name, which is can wreak all kind of havoc if someone decides to rename those. But you can see on update, if the view, if this is my view, if this is my character that I'm controlling locally, map, basically, which is a custom function here, that's going to update the transform position rotation of my local controller from the XR Interaction Toolkit and send that over, synchronize that over the wire using this Photon Network Player class, right? So that's what this does in order to synchronize those elements. And we can see here, we have also a Photon transform view, right? Which is the same one that John or Norm Core provide, where you can decide to change, to update or, optimize your data less granularly, because here you only have, you don't have the XYZ value, which I found a little bit better in Network for Game Object. It's more granular, gives you more control. So that's the avatar, basically. That's what you need to set this up. Locally, I'm using my normal rig, but I'm synchronizing my network, basically, the network version of myself, so it gets sent over the wire, and then I can see the other players' representation in my local running instance of the simulation. They get instantiated by the network player spawner in this case. Then, similarly with Norm Core, we have Photon Sync Complete here, which is more or less the same class. We have the two notifications that get sent. One of those is sent over the network. The other one is handled locally. So locally, I call this notification when I complete a step, as highlighted in episode 8. And then rather than the state machine updating locally when I complete that steps. This class sends that via a pun RPC event, right? So that's what we discussed with John earlier, those remote procedure calls. So this function is going to get executed on all the clients when an RPC call is dispatched, and it's going to get passed this value, which is the current step. And then here, what I do is I'm going to update the progress. Again, I'm using the Visual Scripting event bus, which is built into Visual Scripting, to send a notification saying like, hey, the network complete step has been called, and I passed the step for my state machine to update. So that's will update locally on all the clients, right? And that's a this is an RPC call, as we mentioned. It's the simpler, or the default way of synchronizing or sending events or calling functions across multiple clients. And here there's a nice little filter, so you can see I'm passing the variable the name of the function as a string variable, and then I'm calling this on everyone. So that includes me, the host, but also all the clients connected. Everyone is going to execute that function in order to ensure that we're all in lockstep with each other, that we all at the same step inside the training progress. And then finally, the other variable that we sync are the other two things that we sync are the wheels. So this is pretty much the same. If I go in my scene here, and I'm going to select one of the wheels, you will see that we still have our rigid body. So here, that's interesting because, again, I was following a quick tutorial to make sure that I was doing things right. And I realized that some of these steps are not necessary. So there's a photon view, which allows you to basically grab that object and then synchronize it over the network once it's grabbed. And you have an ownership transfer when you take over. So when you request ownership, you can take over that object and control it yourself. You have also the option of, say, fix, which is whomever basically is the first one by default, or you can request, right? And the request would be like a more authoritative server side kind of thing. Then you decide how you synchronize the position. See, unreliable on change. You can decide whether it's reliable, right? In order to make sure that this arrives, because this is a position. Doesn't matter if we miss a few steps, it can interpolate between the two. And then we have a custom class here, which gets added automatically because we have a rigid body here in this for this object. So that's basically to synchronize the physics across the wire. And then in this example, we extending the photon, the class, or the XR interaction or grabbable. I can show you the class. It's really not much. It's just extend the XR grab interactable, which is the default one when you want to grab an object with XR interaction toolkit. Grabs the photon view. By the way, if you get component like this photon view because you want the component on this game object, in this case, I want to grab this component here. What I like to do is to make sure to add this little attribute, which has required component of photon view. And if you look at here, for example, if someone decide like, you know what, I don't know why this is here, I'm going to remove it. It's going to tell me, no, you can't, because this script is relying on it, right? So I can't remove it. So that's why I put this here, this little attribute. You can ask them to your custom code to make sure that someone doesn't remove this component in the editor and then breaks your system, for example, or gets errors and then has to bother you to debug it. So on select entered here is a built-in function a built-in handler from the XR interactable. And basically all it does is when I grab this with the controller, it requests the ownership from the photon view so that that view will get synchronized over the network, right? Versus and make sure that when I grab the object and move it around, everyone can see the object moving. If we don't do this, you won't have ownership. You can move it locally, but over the network, you won't see that representation carried across. So that's the idea here with this. The reason I say this is not necessarily required, because if you look at your default XR grab interactable, you have a select here, select entered, right? And I can just add here basically a plus, grab that wheel, value, go to my photon view, and then there should be a request ownership, and I can just do it like this. I don't need to have a custom class. It's actually something that I've done in the garage lift setup to request ownership, right? So you can do those here. You don't need to extend this class. Apologies if that was kind of a bit misleading, but I might actually do it before I upload the source code, so it's simpler and we have less moving parts for this project. So once you have that, that's it. You grab ownership when you grab it, and then that gets carried over over the network. And then finally, the last thing is the garage lift, which here we can see the photon sync lift height. Again, we are, rather than use a model like we did in Normcore, we are using a remote RPC. In Netcore for Game Object, you could use a network variable, for example, for this. That's a perfect example because it's just a float that you want to synchronize across all the classes, so the lift moves up and down accordingly. And the only thing is, again, we have a photon view, and I expose this function here, request ownership, but this is being called when I go to step 2, when I raise or lower my lift here. You can see here, I have the lift control panel. If I focus on it, you will see it here. It's got 2 buttons, up and down. And on those buttons, as I highlighted before, I have on activate, which is when I trigger press on while this button is highlighted. I am requesting from the garage list script the sync lift height to request ownership, right? I could technically actually just request ownership directly from the view. I don't know. Yeah, I guess that was just for debug purposes, so I could see what was happening. I did it in this script versus directly accessing the photon view. But again, if the view is mine, which basically I'm controlling it because I pressed on the button, and then the threshold of difference between the previous height and the current one is above, that's 10 centimeters, I guess. Then cache the previous height and then call this RPC method saying like, hey, the height has changed, right? And then this method will get called on all the connected customers, client, sorry, and updates automatically the variable. If you look at this weird thing, variable declarations that set variable name previous height, that's a bit confusing. This is because the lift, if I select it, is using a visual script, right? A script machine, and this is the variable height value that I'm setting. So this is a custom component that gets attached to all the script machine where you can define object variables, and I'm basically setting that variable from my C# script. It's in the documentation. This is how you set variables on a specific object with a variables component attached to it. Let me go to my notes and yep. So activated action, as I mentioned, wasn't necessarily required to do a custom script. You can just do it directly. And that's it for Photon. Everything else basically gets synchronized automatically. Obviously, again, we automatically join this room. I don't even have a UI to specify the name, like the fancy UI John had in his session, right? This is really just very simple. So you would have to build that UI if you wanted to create a custom room and invite people to it, etc. But here, to get started out of the box, that's really all you need in order to interact with the setup. So pretty easy overall. And then in the backend, Photon takes care of allocating all the resources that you need on their backend to synchronize everyone. And obviously, I'm hosting the simulation. It's not being hosted on their end, but they are hosting the relay and the room service, the room setup, room service, yeah, like a hotel, the room setup, the same way that you would have with the lobby. Yeah, and that's it for Photon. Any
Excellent.
questions?
Thanks, Jerome. Yeah, we have a couple questions that are rolled in here. I'm going to try my best with this one. I've written a class that extends Photon network callback, but I can't see a list of rooms when on meeting room update gets called. Any potential solutions there?
You can see a list of rooms. I don't know if that's a feature. No, you just join the room. When you join the room, that's where you get the the callback. So if I go to my network manager, so this is it, right? Pun callback basically gives you a whole bunch of functions that you can listen to, like on connect, on left room, on master client switched, right? On create room fail, on join room fail. So you extend this class to get those events. Any variable that you can't find is because it's not defined here, right? So you need to ping that API to maybe to get a list of room associated with your application or with your backend setup, right? But yeah, similarly, I don't see any. I see mostly lifecycle functions, right? On join random, for example, failed. On move property updates. So yeah, go through the API. There's a lot there. Where is my? No, that's not it. It's down there. Structure. Thank you. There we go. Let's see what variables we have. Yeah, it's mostly event on room properties. I don't see anything. Room list updates, I see here. That might get you the list of rooms, actually. It looks like it does. So I haven't used this. So you check out the API, but it's there. I mean, there's something there that might suit your need. Hopefully that helps.
All right, looks like we've got one more question here before we head out. Which of the network systems you mentioned would be the best for VR game making right now?
That really depends. Also it depends on the platform, because if you want to do something, for example, on the Quest, and you want to tap into the Meta avatar system, then you should really do something dedicated with that. They have their own systems in order to synchronize experiences. So check out, Steam. Also, Steam VR have their own. I believe their own relay, their own matchmaking. They all kind of have their own services. So across the board, you can use something that's multi-platform like Photon, but depending on your game specifics or your experience specifics, it's there's no better. I think, as John mentioned earlier, it's look at the various options, the pros and cons, ask in the forum maybe, or in their Discord server, for specific questions or specific issues that you may highlight for your use case, and then from then on decide what you use. It's not an easy decision, because it's such a core component of your game. It also depends on the type of game you are doing.
Yeah, and just to tag on that, I would recommend that if you're thinking about building something, multiplayer, think about that first. A lot of people try to, make a whole game and then come back and just make it multiplayer, and that's usually a recipe for pain. So if you're thinking about making your game multiplayer, you want to start kind of thinking about that architecture now. Like, you got to understand, where is the code going to be running? Is it going to be hosted on a client? Do you need, security? Do you need authentication? How's it going to work? How's it going to link up? And as you're answering those questions, that'll help you evaluate those different options of which one you think is best for you.
Awesome.
All right, excellent.
I see someone in the chat, Ranga, asking if you always love the skid loader. If possible, is there a way to grab the model? It's in the project on GitHub already. Go to session 8. I think we've been using it throughout. There's at least three full projects, and it's in there.
Yeah.
We may even have the forklift. There's also a forklift similar to the skid loader. John is, it's definitely your favorite skid loader of all time, right? Because you spend so much time with that thing.
I don't know what you're talking about.
PTSD. So if you haven't seen it, maybe we should post the link in the forums, the brilliant Timmy skid loader demo, which is a configurator demo that John and the team build, and is absolutely fantastic using the same data sets. It has all kind of fancy things like render on demand and exactly Timmy.unity.com. Thank you, John. Check it out. It's your trusty skid loader, but it's available on the GitHub repo, so you can get the assets from there.
All right, awesome. And if that's it, just checking our chat one last time. Looks like it's all thank yous and goodbyes. So with that, thanks again, everybody, for joining for today's session. And again, big thanks goes to Ben Radcliffe, co-creator of the series, who couldn't be here today, as well as Jerome, John, Vanessa, all of our organizers as well. So please keep an eye out for a follow-up email containing links to resources mentioned in today's talk. Please check out the forums as well. One last post of the survey into the chat here before we go.
Thank you, Drew. Oh, should I
problem.
mention they can cut it if they don't want to to share that information. But this week we just passed 3,000 registered people for this specific episode and the next one. So that's really nice. We went over 3,000 before, but that was including Unity employees. There's about 130 employees at Unity that signed up for this series. But I'm very happy to announce that we have over 3,000 participants from the community. Thank you. And you know, I want at least 3,000 fill outs in that survey, right?
Exactly. We don't expect less.
For sure. Yeah, thanks again to everybody for making that a reality.
Yeah, it's fantastic.
Definitely,
Amazing.
yeah.
Thanks all.
All right, and yeah, with that, I guess our final session will be next month for Road to the Metaverse Creator Series. So we'll hope to see you there. And yeah, take care, everybody. We'll see you next time.
Thank you, John.
Bye-bye.
Thank you, Vanessa. Thank you, Drew.
Thank you,
Thanks, all.
guys.
Thanks,
See you
everyone.
next time.